Hello everyone. In this video, we will solve a JEE Main previous year question based on the binomial theorem. Let us carefully understand the problem and learn how to approach this type of question. This question was asked in January 2026 session. Let's get started. Let us first carefully observe the problem. In the problem, it is given that left hand side some relation of binomial coefficients and right hand side also the relation of binomial coefficient involving one parameter alpha, that is alpha power 30. Then asked find the value of 30 alpha. So if we see carefully the problem, in the left hand side all the nth values are same, that is 15, and right hand side all the values nth values are same, that is 14. So 15 and 14, that is decreased by 1. In this case we are write the general term of this left hand side. So how to write the general term of this left hand side? So first is, that is first term, that is second term up to nth term. So that terms are in the product. Let us define the general term TR of the left hand side is equal to, that is suppose first term, so that is 0, that is 1, so that is R minus 1, we say that is R. So 1 over 15C R minus 1 plus 1 over 15CR, that is the general term, and this term are product. Suppose that is T1, the second term is T2 up to T13. So we put R is equal to 1 to up to 13. So when we put R is equal to 1, the first terms, then R is equal to 2, that is second terms up to T13, the last term. So our goal is to convert these two terms 15CR minus 1 and 15CR into 14C something. So in this case we use two identity of the binomial theorems to convert 15CR minus 1 and 15CR to 14C something. So first identity is NCR is equal to N over R N minus 1 CR minus 1, that is N and R both are decrease, N minus 1 and R minus 1. And second identity is NC R minus 1 is equal to N over N minus R minus 1 N minus 1 C R minus 1. In this case only R is decreased by 1 and R minus 1 remains same. Earlier we defined the general term TR is equal to 1 over 15C R minus 1 plus 1 over 15CR. Now we use these two identity here and here to convert it 14C something. Therefore 1 by 1 we calculate. Suppose first we calculate 15CR. So 15CR, use this identity. So 15CR is equal to 15 is nth value, n R is R, n minus 1 is 15 minus 1, that is 14 C R minus 1, and second term is 15 C R minus 1, that is use this identity here, n C R minus 1, that is n is 15 over n is 15 minus R minus 1, n minus 1 is 15 minus 1, that is 14 C R minus 1 is R minus 1. Now we calculate it, 15, that is 15 plus 1, that is 16 minus R 14 C R minus 1. Now we put the value on TR, that is 1 over 15 over 16 minus R 14 C R minus 1, that value, and also put that value here. So that is 1 over 15 over R 14 C R minus 1. Therefore if we see carefully, 14 C R minus 1, 14 C R minus 1, this term are same. So we common it out, 1 over 14 C R minus 1, that is 1 over 15 over 16 minus R plus 1 over 15 over R. Now we calculate it very carefully, 14 C R minus 1, that is 16 minus R over 15 plus R over 15. Therefore 1 over 14 C R minus 1, the LCM is 15, so LCM is 15, 16 minus R plus R. Therefore this R and this R are cancelled. Therefore 1 over 14c r minus 1 16 over 15. Therefore, we got TR is equal to 1 over 14c r minus 1 16 by 15. That is the general term of this left hand side. So that is valid for r is equal to 1 to up to 13. Therefore, we put this value TR in the left hand side. Left hand side is T1, T2 up to T13. So we put 1 by 1. So when we put r is equal to 1, that is 1 over 14c0 16 by 15, 1 over 14c0 16 by 15. When we put r is equal to 2, 1 over 14c1 16 by 15, 1 over 14c1 16 over 15 up to T13. When you put T13, that is 1 over 14c12 16 by 15, 1 over 14c12 16 over 15. Therefore, we write it 14c0 into 14c1 up to 14c12, and 16 by 15 are everywhere. So how much time? So 13 times, so 13 times 16 by 15 power 13. Now we match left hand side is equal to right hand side. So left hand side we got 1 over 14c0 14c1 up to 14c12 into 16 by 15 power 13, and right hand side given that alpha power 13, 14c0 14c1 up to 14c12. Therefore these two terms are same, and the both hand side this term and these terms are cancelled. Therefore we got 16 by 15 power 13 is equal to alpha power 13. This implies alpha is equal to 16 over 15. In question asked find the value of 30 alpha. We got alpha value, so we put here 30 times, that is 16 by 15, that is 2. So 2 times 16 is equal to 32. Therefore 30 alpha is equal to 32. This is the answer of this question. So overall the questions we put two identity. First identity is NCR, that is n over r, n minus 1 cr minus 1, and second identity we use here NCR minus 1, that is equal to n over n minus r minus 1, n minus 1 cr minus 1. These two identity used in this question. Using these two identity convert to 15c something to 14c something. Then we match left hand side is equal to right hand side. Then we got the value of alpha, and we got the value of 30 alpha is equal to 32. Let us carefully observe the problem. In a problem given that s is equal to some expression in factorial up to 13 terms, and also given that 13s is equal to 2 power k over n factorial, then ask the find the value of n plus k. Now s is equal to given that 1 over 25 factorial plus 3 factorial 23 factorial plus 5 factorial 21 factorial up to 13 terms. So this type of question we are just write the general term of this expression s, and also find the 13 term also. How to find the 13 term? If you observe the question, if you see the pattern, it is 1 factorial here, 1 factorial, then 3 factorial, then 5 factorial up to 13 terms. So how to find this 13 term? If we see 1, then 3, then 5 up to 13 terms. So it is an AP series. AP series, how to find the AP series term? Tn, suppose Tn is the nth term. AP series, A is the first term, n minus 1 into D. D is a common difference. Therefore A is 1 and T13 we need. So 13 minus 1, D is increased by 2, 1, then 3, then 5. So it is 2. So therefore 1 plus 12 into 2, it is 24 plus 1 25. Therefore up to 25 factorial into 1 factorial, and because 1 factorial is 25, 23, 21, it is decreased by 2, it is increased by 2, so it is up to 13 terms. That means it is going 25 factorial 1 to 135 up to 25, and 25 is decreased to 1 factorial. So our S actually 1 factorial, 25 factorial, 3 factorial, 23 factorial up to 1 over 25 factorial into 1 factorial. Therefore, we got S is equal to 1 over 1 factorial, 25 factorial, 3 factorial, 23 factorial, 1 over 5 factorial, 21 factorial up to 25 factorial into 1 factorial. Now we want to write the general term of this sum. Let TR is the general term. So in general term, above part is 1 and it is going 1, 2, 3, 1, 3, 5 up to 25. So it is odd term 1, 3. How to write the odd term? 2R minus 1 and is factorial, so it is factorial as it is, and 25, 23, 21. So it is 25, 23 up to 1 factorial. It is going back to 1. So how to write this term? It is odd term but it is decreased by minus 2. So how to write? If you write 25, how to write 27 minus 2 in this way? So it is right 27 minus 2r factorial. Therefore we got the general term is 1 over 2r minus 1 factorial, 27 minus 2r factorial. So we need to show 25, 23, 21 factorial. If we put r is equal to 1, then 27 minus 2 is 25 factorial. R is equal to 2, 27 minus 4. 27 minus 4 it is equal to 23 factorial. It is okay. And similarly r is equal to 3, it is 21 factorial, and so on. R is equal to 13, it will be 1 factorial. So we got TR is equal to 1 over 2R minus 1 factorial, 27 minus 2R factorial. Therefore S is equal to summation over R is equal to 1 to 13 over 2R minus 1 factorial, 27 minus 2R factorial. So our goal is to write is 13s is equal to 2 power k over n factorial. So we want to write this term as a compact form. So in this case, if we observe this term carefully, we see a pattern. If we multiply by 26 factorial here, so 26 factorial also here, if we forcefully multiply 26, so this 26 factorial and 26 factorial are cancelled, and rest of are same. 2r minus 1 factorial, 27 minus 2r factorial. Therefore S is equal to r run for 1 to 13, 26 c 2r minus 1 over 26 factorial. Why this term 26c 2r minus 1? If we break this 26c 2r minus 1, we see 26 factorial, 2r minus 1 factorial, and 26 minus 2r minus 1 factorial. That is 26 factorial over 2r minus 1 factorial and 27 minus 2r factorial. That is exactly here. This term is here. So that is we write 26c 2r minus 1, that is equal to 26c 2r minus 1. Now we break this term. Also this 26 factorial is come outside the summation. 26 factorial r run from 1 to 13, 26 c 2r minus 1. Now we break this summation. 1 over 26 factorial, that is r is equal to 1, that is 1, 26c1, r is equal to 2, that is 3, 26c3 up to 26c25. So s is equal to, we got 1 over 26 factorial, 26c1, 26c3 up to 26c25. We know that, we write as a note here the ordered term sum of this binomial coefficient. Suppose c1 plus c3 up to ordered term is equal to 2 to the power n minus 1, sub 2 to the power n minus 1. Here also same things, c1 c2 means n c1 plus n c3, that is n c n minus 1, that value actually 2 to the power n minus 1. Now we use this value here, so we got 26c1 up to 26c25 is equal to 2 to the power n minus 1, n is 26, 26 minus 1 is equal to 25, 2 to the power 25. Thus s is equal to 1 over 26 factorial, and this summation part is 2 to the power 25. Therefore we write here 2 to the power 25 is equal to 1 over 26. Now we break 26 factorial as 26 into 25 factorial, because n factorial is equal to n into n minus 1 factorial is equal to n into n minus 1 into n minus 2 factorial. In this way we break it, and here 2 to the power 25. Now our actual goal is to find the 13s. S is equal to, we got here, therefore 13s is equal to 13 multiply over 26 into 25 factorial into 2 power 25. So 13 and 26 cancel by 2, so it will be 2 to the power 25 over 2 into 25 factorial. Now our goal is to write 13s is equal to 2 power k over n factorial. Now we got 13s is equal to 2 to the power 25 over 2 into 25 factorial. So that is 2 and 25, it is 2 to the power 24 over 25 factorial. And given that 13s is equal to 2 to the power k over n factorial, so it is equal to 2 to the power k over n factorial. Now we match n and k, we got n is equal to 25 and k is equal to 24, and the question asks what is the value of n plus k. Therefore n plus k is equal to, n is 25 plus 24, that it is equal to 49. So this is the answer. And also in the option 8 we will see that the option 2 is 49, so option 2 is correct. In the overall question, in the question given that s is equal to some expression of the factorial, then we see that one pattern follows this sum of this factorial. Then we write the general term tr of this of s, and s can be write as a summation r is equal to 1 to 13 tr. Then we evaluate this and we got this value actually 2 to the power something over some factorial. After that we calculate 13s and we will match is 2 to the power k over n factorial. Then here we find k and n, and we got n plus k is equal to 49. This is the our answer. Let us carefully observe the problem. In question it is given that this expression and coefficient of x is minus 56 and coefficient of x and x cube both are 0. Then find the value of a plus b plus c. Now write it clearly, this expression ax square bx plus c into 1 minus 2x power 26. So we find the coefficient of x, x square and x cube of this expression. Now we break this expression in binomial expansion. Ax square plus bx plus c as it is 1 plus 26c1 minus 2x power 1 plus 26c2 minus 2x power square 26c3 minus 2x power cube up to minus 2x power 26, because we need the power of x cube, so we expand up to my of the coefficient of x cube. Now ax square plus bx plus c 1 minus 2 times 26c1x plus 4 26c2 x square minus 8 times 26c3 x cube and so on minus 2x power 26. Now we find the coefficient of x first. Compare this to find the coefficient of x. Here the x and here x. So if we multiply c by this term, then we will get the coefficient of x, and the multiply b by 1, then we get the coefficient of x. Therefore the coefficient of x is equal to b plus c times 26 to minus 2, so it is equal to b minus 52c, and given that the coefficient of x is equal to minus 56, according to the question b minus 52 c1 is equal to minus 56. We numbering this is 1. Now we find the coefficient of x square. Here x square here and x square this. So we multiply c by this term, then we will get the coefficient of x square, and we multiply a by this term 1, then we get the coefficient of x square, and also we multiply x term and this x term, then we get the coefficient of x square. So b by multiply by this term. Therefore the coefficient of x square is equal to a plus c 26 c2 into 4 plus b 26 c1 minus 2. Therefore we write is clearly a. Calculate this 26 c2 is equal to, using this as a note we write ncr, that is ncr is equal to n factorial over r factorial into n minus r factorial. Use this formula here and here, then we get this expression. Total expression is 1300 c minus 52 b. Now according to the question, a plus 1300 minus 52 b is equal to 0. It is given that, so numbering it 2. Now we find the coefficient of x cube. How to find this? So c, when we multiply c by this x cube coefficient, then we will get the coefficient of x cube, and when we multiply b by x square term, then we will get the coefficient of x cube, and when we multiply x square term a by x term, then we will get the coefficient of x cube. Therefore the coefficient of x cube is a 26c 1 multiplied by minus 2b times 26c2 multiplied by 4 plus c 26c3 multiplied by minus 8. Now we calculate it, then we get 52a plus 1300b minus 20800c. Using same thing NCR formula, n factorial over r factorial n minus r factorial, here and here also. Now the according to the question, this term also 0, minus 52a plus 1300b minus 20800c is equal to 0. So numbering it, now we got 3 equations. we have three equation and three variable, so it is solvable and find the value of a, b, c. Now question is how to solve these three equations. Now see the process. First, from the equation 1 we write b is equal to in terms of c and put it here, then we get a is equal to in terms of c, then put the value here a and b, then we find the value of c. So from the equation from 1 b is equal to 52 c minus 56, numbering it 4. Now substituting, putting in 2, we get a plus 1300 c minus 52, put the value of b 52c minus 56 is equal to 0. Now calculate it very carefully. Everyone take a mistake here. So a plus 1300c minus multiply this 2704c plus minus minus plus 2912 is equal to 0. Now arrange this. A is equal to 1404c minus 291. Now number 8 5. Now we get the two value b in terms of c, also a in terms of c. Now we put the value a and b here and total expression will get c is in terms of c. Therefore substituting the value in 3 we get, so put the value, equation 3 is minus 52, so we put value of a first, minus 52, a value is 1404c minus 2912, then 1300, then the put the value of b 52c minus 56 minus 20800, c is equal to 0. Imply that then we divide by minus 52 whole terms, so we will get 1404c minus 2912, that is minus 25 52 minus 56, that is plus 400c is equal to 0. This imply, so we arrange these c terms in left hand side and number in right hand side. So we will get 1404c minus 1300c plus 400c is equal to 2912 minus 1400. This imply 504c is equal to 1512. This imply c is equal to 3. So we get 3 is equal to 3. Therefore we put in equation 5. So we will get, we put c is equal to 3, then we will get a is equal to, then we will get the value of a. Therefore substituting in 5 have a is equal to 1404 into 3 minus 2912, then it will gives 1300. Now rest is b. See the equation 4, b is equal to minus 52, c, put the value of c, then we will get the value of b. B is equal to 52 times c is 3 minus 56. So multiply this, so we will get 100. Therefore a is equal to 1300, b is equal to 100 and c is equal to 3. Therefore value of a plus b plus c is equal to 1300 100 plus 3, that will be 140. So answer option 3 is the correct answer. Now observe these questions. It is given this expression 1 plus x square 1 plus x power n and asked the sum of all possible values of n, the coefficient of x, x square and x of this expression are in AP. So we expand this expression 1 plus 2x square plus x power 4 a plus b whole square formula and expand this in binomial expression 1 plus nc1x plus nc1 x square. We need the coefficient of x, x square and x cube. So we expand up to x cube, and that is nc2, nc3, x cube, and last term is x power n. So when we find the coefficient of x, so we need only here, and there are no x term in here, so only x coefficient is nc1. So we find the coefficient of x, then x square, then x cube. So one by one we find. So coefficient of x of this expression, whole expression, is nc1, that is actually n. Next, coefficient of x square. How to find the coefficient of x square? This term is x square, so we multiply this term by this term, then we get the coefficient of x square, and also the coefficient of x square here, so we multiply this term by 1, then we get the coefficient of x square. Rest of are the higher power of x, so we only multiply by 2 by 1 and nc2 by 1. So the coefficient of x square is equal to 2 plus nc2, that is actually 2 plus nc2. Here we write note, formula of NCR is equal to n factorial over r factorial n minus r factorial. So using this formula we expand this 2 plus n factorial over 2 factorial n minus 2 factorial, that is actually 2 plus, and also n factorial is equal to n into n minus 1 factorial, so n into n minus 1, and n minus 1 using same formula is n minus 2 factorial over 2 factorial n minus 2 factorial. So this 2 factorial n minus 2 factorial, n minus 2 factorial cancel, so 2 plus n minus 1 into n over 2. So 2 factorial means 2. So third, we find the coefficient of x cube. So how to find the coefficient of x cube? So x is square here, so coefficient of nc3, so it is multiplied by 1, then we get the coefficient of x square here. Also coefficient of x multiplied by coefficient of x square, it is coefficient of x cube. So these two terms are the coefficient of x cube. Therefore the coefficient of x cube is nc3 plus 2 times nc1, that is actually we break this nc3 this formula using this formula, real over n minus 3 factorial into 3 factorial plus nc1 means n factorial means n into n minus 1 n minus 2 n minus 3 factorial over n minus 3 factorial into 3 factorial. 3 factorial means 3 into 2 into 1 plus 2n. This term and this term are cancelled, so final term is n into n minus 1 into n minus 2 over 3 into 2 6 plus 2n. Now we get the coefficient of x, x square and x cube, and the question it is given that this coefficient are AP, that means three numbers, suppose A, B and C, these are in AP, means the difference are same, this minus this and this minus this are same, so B minus A is equal to C minus B, so B are the same side, so B, that is 2B is equal to A plus C. This implies B is equal to A plus C by 2, that means 2 times of the second term is equal to first term and third term. So using this condition of these three number, a coefficient of x square and coefficient of x cube, therefore 2 times coefficient of x square, second number is the coefficient of x square, so 2 times 2 plus n into n minus 1 over 2 is equal to, first term is n plus third term is 2n plus n into n minus 1 into n minus 2 over 6 Now we calculate this equation. This is the equation of n. Now we find the values of n. We multiply to it is 4 plus 2 to cancel, n into n minus 1 is equal to n plus, here it is a little mistake, so it is 2n plus n into n minus 1 n minus 2 over 6, this term. So multiply 6 both side or minus n, that is n plus n 3, and multiply by 6 it is 18n plus, we multiply this n square minus n and n minus 2, and we simplify this equation, then we get a cubic equation of n, that is actually n cube minus 9 n square plus 26 n minus 24 is equal to 0. If we carefully calculate this equation and break all terms, take the left hand side, then we get these equations. Now we solve these equations by heat and trial method. So how to find the values of n in the cubic equations? So we put nth value randomly 1, 0, minus 1, etc, etc, such that if we put n is equal to 1 in this equation, n is equal to 1, then 1 minus 9 plus 26 minus 24, it is not equal to 0. So we check another values of n. Suppose n is equal to 2, that is 8 minus 9 into 4 plus 26 into 2 minus 24, that is 8 minus 36 52 minus 24, that is actually 0. So n is equal to 2 is a solution of this equation. So that is n minus 2 is a factor of this equations. This n minus 2 is a factor, so we try to find another factor which is the quadratic terms. So n minus 2, how to find this quadratic terms? So see, n minus 2 is a factor, so n minus 2 we first make this n cube. So how to get n cube? N minus 2 is a factor, so n minus 2 multiplied by n square, so n cube is adjust, and second minus 2 n square is our hand. So our actually need minus 9 n square. So how it is come? So n minus 2 is a factor, so n minus 2 is right here, so minus 7 n. So minus 7n and minus 2n square, it is minus 9n square. Then plus 7 into 2, 14, we need 26. So how much is left? 12 terms. So 12n minus 24 is equal to 0. So n minus 2 is common over n square minus 7n plus 12, that is plus, is equal to 0. So we get two product, n minus 2 is a linear, is a quadratic, so it is break it easily, it is n minus 2, that is n minus 3 n minus 4 is equal to 0. Therefore the nth values are 2, 3 and 4, and in the question asked find all the values of n and sum it. Therefore the values are 2, 3 and 4, therefore the sum and sum it 3, 2 plus 3 plus 4, that is actually 9. So option 4 is the correct answer. Therefore in the overall problem we are just break the expansion 1 plus x square 1 plus x power n in the binomial expansion and find the coefficient of x square and x cube. Then we get the coefficient of these terms are in the nth form, and also one condition and given in the question, these coefficients are AP. So we use the AP formula to B is equal to A plus C. A, B, C are AP, then this condition are hold. So using this condition we find the values of n. We get the 3 value and sum it, then we get the final answer is equal to 9. That is option 4 is correct. Observe the term in these questions. Here the first term is 100 C50 over 51. Second term is 100 C51 over 52, and last term 100 C 100 over 101. So see, the nth values are fixed hundreds, but Rs values are increase 50, 51 and to 100. But in over term is 51. That is we write 50 plus 1. That is right 51 plus 1. So this pattern is R plus 1. So here we use a beautiful identity which is given in this binomial theorem. I write this as a note: NCR over R plus 1 is equal to 1 by n plus 1 n plus 1 C R plus 1. So we convert each term using this identity. So that will convert to a nice form. So first term we will convert 100 C 50 over 51. So that will convert to, so nth value is 100. So 1 upon 101. N plus 1 is 101. C R plus 1, R is 50. So it is 51. Second term is 100 C 51 over 52. That will convert to 1 over 101. Nth value is 100. So it is 101. That is n plus 1. N plus 1 is 101. C Rth value is 51. So it will convert to 52. The last term is given 100 C 100 over 101. So that will convert to 1 over 101. N plus 1 is 101 C 101. So 100 C 50 over 51 plus 101 upon 52 up to 100 C 100 over 101. So it will be convert to 101. First term is 101 C 51. 101 C 51. Second term is 1 over 101. 101 C 52 up to 1 over 101. 101 C 101. So each term is contain 1 over 101. So it will go over common. 1 over 101. 101 C 51 plus 101 C 52 up to 101 101. So we need to calculate this term only. Here common is out 1 over 101. So now 101 C 51 101 C 52 up to 101 C 101. So we know that NCR is equal to NC n minus R. So using this identity we will convert each term 101 C. So that will convert to n minus R. So n is 101 minus 51. That will be convert to 50 plus 101 C 49 up to 101 C 101 minus it is 0. So actually that will be R is equal to 0 to 50 101 C R. So we need to calculate this term, what will be the value. Also we know that summation over R is equal to 0 to n NCR is equal to 2 to the power n. So Here we apply n is equal to 101. This summation r is equal to 0 to 101. 101 cr is equal to 2 to the power 101. Now we break this term 101 c0, 101 c1 up to 101 c 101 is equal to 2 to the power 101. See carefully, first term is 101 to c0 up to 101 to 1. So somewhere it is one term is c101 c50, after that 101 c51 up to 101 c101 is equal to 2 to the power 101. So we break this whole term in two parts. First part is this, second part is this. Previously we see this term 51 to 101, it is converted to 0 to 50. So now we write this term 51 to 101, it will be 0 to 51. So this term is 2 times is equal to 2 to the power 101. So we write 101 c0 up to 101 c50 plus same thing 101 c0 up to 101 c50 is equal to 2 to the power 101. So now it will be 2 times 101 c0 up to 101 c50 is equal to 2 to the power 101. So this implies 101 c50 up to 101 c50 is equal to 2 to the power 101 upon 2. So that will be 2 to the power 100. Now we get 101 c0 101 1 up to 1050 is equal to 2 to the power 100. So here our term is this term, we simplify this is equal to this, so we got this term is equal to 2 to the power 100. So whole term is 1 upon 101 into 2 to the power 100. So our answer is 1 upon 101 into 2 to the power 100. So check this answer 2 to the power 100 by 101. This is the correct answer. See this answer. This is fourth term. Fourth option is 2 to the power 100 by 101. So fourth option is correct. First we observe the question carefully. So it is given that 1 plus x or 1000 plus x 1 plus x power 999 and so on x power 1000. So in question it is to find the sum of the coefficient of x power 499 and x power 500. So if we find individually each term the coefficient of x power 499 and x power 500 and sum it, it is very difficult to find the sum of these coefficients. So in this case we approach another method. If we see carefully the expression of this problem, it is given 1 plus x per 1000 plus x plus into 1 plus x to the power 99. So here 1 plus x to the power 1000, then decrease by 1, but x is involved, so it is multiplied by x, but 1 plus x divide, and so on in this case. So in this case if we multiply x by 1 plus x by first term, this term by first term, then we will get second term x into 1 plus x to the power 999, and if we multiply this term by this term, then we will get third term x square 1 plus x to the power 998. So in this case we get an GP series whose first term a is 1 plus x power 1000 and common ratio r is equal to x by 1 plus x. So if we find the sum of the GP series, then we get the sum of this expression. So if we know the sum of the GP series, like we write a note here. Suppose the GP series AR square up to AR power n minus 1. So A is the first term, AR the second term, AR square third term, and R is the common ratio. Then the sum, GP series sum S is equal to A first term, R to the power n minus 1 by R minus 1 if R is greater than 1. If R is less than 1, A R to the 1 minus R to the power n over 1 minus R if R is less than 1. So depend on R, the GP series sum divide it two terms. First term is if R greater than 1, then GP series sum is this. If R is less than 1, then GP series sum is this. So our case, the R is this, x over 1 plus x. This is strictly less than 1. So we apply this sum formula. S is equal to first term into 1 minus R power n over 1 minus R. So our problem is x power 1000, then x into 1 plus x power 999 up to x power 1000. Sorry, it is 1 plus x. So first thing, find the number of terms are involved in this expressions. First term power is 1000 and the last term is 1 plus x is not here, means it is 0. So we find the term, how many terms are involved. It is the easy formula to the first number is 1000 minus 0 plus 1. So it will be 1001. This is the number of terms. This is actually n. So this sum is equal to, suppose it is denoted by s, and the first term is 1 plus x power 1000. It is r is less than 1, so we apply this formula. 1 minus r is x upon 1 plus x, and n is 1001 over 1 minus r. R is x over 1 minus x. So now we simplify this term very carefully. 1 plus x power 1000, the LCM over here, 1 plus x power 1001 over 1 plus x power 1001 minus x power 1001, and this term is here 1 plus x minus x over 1 plus x. This term is cancelled. Now s is equal to 1 plus x power 100 x power 1001 minus x power 10, it is 1 plus x. So if we see 1 plus x power 1 plus x power 101, this term is here 1 plus x by 1, so 1 plus x by 1. So now that is 1 plus x, that is 1 plus x power 100, that will be get 1 power 1001, and this term is rest of are same, 1 plus 1001 minus x power 1001 over 1 plus x power 1001. So this term and this term are cancelled. So the final term will get 1 plus x power 1001 minus x power 1001. In the question, our actual we finding x power 499 and x power 500 coefficients. So sum will get x power 1001 minus x power 1001. So only term are involved x power 499 and x power 500. These term are only here. So we expand this term 1 plus x to the power 1001 in binomial expansion. So we will get 1 plus 1001 c1 x plus 1001 c2 x square and so on. So we will find 1001 c 499 x power 499 plus 1001 c 500 x power 500 and so on. In last term is x power 1001. So only the coefficient we need this coefficient and this coefficient. So sum of this coefficient, sum of coefficient x power 499 and x power 500 is equal to 1001 c 499 plus 1001 c 500. So only we calculate this sum. Now we want to find this sum 1001 c 499 plus 1001 c 500. Remember one thing, in binomial theorem one identity as well is known as the Pascal identity. Pascal identity tells us, if we write its note, the Pascal identity is NCR minus 1 plus NCR is equal to N plus 1 CR. So it is N, left hand side is N is same, but R term is R minus 1 and R. Then it will be get N term is increased by 1 and the bigger R is here. So in same identity is used here. Same 101 and 10 are same, nth values are same, but the R minus 1 teams term, that is R. So that will use the Pascal identity. This sum will get 1002 C 500. That is 1002 500. In the overall question, we use GP series, and this GP series sum is S is equal to A is 1 minus R power n over 1 minus R, because our R is less than 1, and then we find the sum of this GP series equation, that will get 1 plus x power 1001 minus x power 1001. Then we expand this term in binomial coefficients, that is 1 plus x 1001 c 1 up to in term minus x power 1001. This term is not used because we find the coefficient of x power 499 and x power 500. So only term are involved here. This sum, we get the coefficient sum, then we use the Pascal identity, then we will get the final answer is 1002 C 500. This is the answer, and option A is the correct answer. Now let us carefully observe the questions. In the questions asked, find the coefficient of x power 48 in this expression. Expression is 1 plus x plus 2 1 plus x whole square plus 3 1 plus x power q up to 100 into 1 plus x to the power 100. So if we find the coefficient of x power 48 in this expression, so it is very difficult to find each of the expression to find the coefficient of x power 48. So if we find the coefficient of x power 48 in this expression, so we start with like that: 48 1 plus x power 48 up to 100 1 plus x power 100. So start with here to end this. So it is very difficult to find the coefficient of x power 48 each of the terms. So now we approach the another method to find the coefficient of x power 48. Let us clearly write this total expression, and it is denoted by s is equal to 1 plus x plus 2 times 1 plus x whole square 3 times 1 plus x whole cube up to 100 1 plus x or 100. Now we multiply the above expression by 1 plus x. So it is changed by very nicely. 1 plus x into s. So it is multiplied by 1 plus x. Then this term is reduced to 1 plus x whole square. Then second term is 2 times 1 plus x whole cube plus 3 times 1 plus x 4, and this term, before this term it is 99 1 plus x power 99. So 99 1 plus x to the power 100 plus 100 1 plus x power 101. Now we numbering these two expression 1 and 2. Now we subtract these two expression 1 minus 2 we have. Then we get s minus 1 plus x. S is equal to, if we subtract this from this, so this term is same 1 plus x. We subtract this from this, so 2 minus 1 is 1. This is 1 plus x whole square. 3 minus 2 is 1. Then third term is 1 plus x cube up to this minus this is 1 plus x to the power 100, and last term is minus 100 1 plus x power 101. So the left hand side is s minus 1 plus x into s. So it is x into s, and right hand side we see 1 plus x plus 1 plus x whole square up to 1 plus x to the power 100. If we carefully see this expression, so we get an GP series. The first term is 1 plus x, second term 1 plus x, so we multiply by 1 plus x. So 1 plus x, which is the first term, second term 1 plus x, the common ratio is 1 plus x up to 1 plus x power 100, and last term is 100 1 plus x power 101. Now we apply the GP series sum property. Suppose the GP series is AR square up to AR power n minus 1. The sum property is equal to AR power n minus 1 R minus 1. If R is strictly greater than 1, if is strictly less than 1, then the sum is 1 minus R power n 1 minus R if R is less than 1. So we apply this sum property here. Our expression is x into s is equal to, first term is 1 plus x and common ratio is 1 plus x. So 1 plus x, and how many terms are here? 1 2 up to 100. So the terms are, the number of terms in GP series 100 minus 1 plus 1, so it is 100. So nth value is 100, that is actually n. So here is 100 minus 1 over 1 plus x minus 1, and the last term is same, last term is minus 100 1 plus x power 101. Now we simplify this expression. Is 1 plus x over 1 plus x power 100 minus 1 minus 1 plus 1 cancel. Now it is rest is x and minus 100 1 plus x power 101. Therefore s is equal to 1 plus x power 101 minus 1 plus x over minus x square plus 100 1 plus x power 101 over x. So we divide minus x in right hand side. Therefore s is equal to 1 plus x 101 over minus x square plus 1 plus x over x square plus 100 1 plus x power 101 over x. Now we find the coefficient of x power 48 here and here. This is 1 plus x over x square. So x power 40 is not is here. Now we expand this term in binomial expression and this term and this term. So s is equal to minus 1 plus x power 101 over x square plus 100 1 plus x power 101 over x plus 1 plus x over x square. Now we expand 1 plus x power n, it is general term is 1 plus nc1. We write as a note x nc2 x square up to nc n x power n. Now if we expand this 1 plus x power 101, so 1 plus 101 c 1x and so on 101, we find the coefficient of x power 48 and here is divided by x square, so we need to find the coefficient of x power 50. So x power 50 is 101 c 50 x power 50 and last term is x power 101, and we find the coefficient of x power 48 from here, so it is divided by x, so we need to find the coefficient of x power 49 from here. So we expand this term in binomial expansion 101, same expansion, same things. We need to find the coefficient of x power 49 is 101 c 49 x power 49 and rest of are same. So we take the coefficient of x power 50 from here and x power 49 from here and put it here. Therefore the coefficient of x power 48 for s is equal to minus 101 c 50 plus 100 101 c 49. This is the coefficients of x power 48 of the given problems. Now we clearly write it 100 101 c 49 minus 101 c 50. So if we see the option of this question, it will be in the option 3. So option 3 is the correct answer. Now overall the question we are doing, we take total expression, it is denoted by s. The expression is 1 plus x plus 2 times 1 plus x whole square up to 100 1 plus x power 100, and we multiply 1 plus x over s, it will get 1 plus x power 2 times 1 plus x power q up to 100 1 plus x power 101. Then we subtract this term that is denoted by 1 and denoted by 2. We subtract 1 minus 2 and we will get an GP series, and find using the GP series sum property we will find the sum of this s, and this is the nice form we get, and we find the coefficient of x power 48. that is very easy to find in this process to finding the individual of this coefficient of the expressions. So answer we, the coefficient of x power 48 of s is 100, 101, c 49 minus 101, c 50. This is the correct and final answer. Now let us carefully observe the questions. In question given that CR denoted the coefficient of x power r of this binomial expression 1 plus x power n, and also given that Pn, one expression is involved in CR, then find the value of 1 over P of 2n and summation run for 1 to 25. Now this question is mainly based on this Pn, so we focus only this Pn. So Pn is equal to C0 minus C1 plus 2 square over 3 C2 minus 2q over 4 C3 and so on minus 2 to the power n over n plus 1 Cn. Therefore, we write this expression in summation form. Then summation we vary r is equal to 0 to n minus 2 to the power r over r plus 1 Cr. So if we put n is equal to 0, then this expression is C0. If we put n is equal to 1, then this expression is C0 minus C1. So if we put here r is equal to 0, then this expression is C0. R is equal to 1, this summation gives C0 minus C1. So it is verified that this Pn is right correctly. Now we apply a binomial identity here such that this expression is converted to a nice form. Now we write a note. This binomial identity is NCR over r plus 1 is equal to 1 over n plus 1 c r plus 1. So we use here CR is equal to NCR. It is denoted the binomial coefficient of this expression. So this expression means NCR. Therefore, write this summation and use this identity. This summation convert to r is equal to 0 to n minus 2 to the power r 1 over r plus 1 CR, that means 1 over n plus 1 c r plus 1. Now see carefully, the summation run for r is equal to 0 to n, so this variable is r. So 1 over n plus 1, this term is come outside the summations. Therefore En is equal to 1 over n plus 1 summation run for r is equal to 0 to n minus 2 to the power r n plus 1 c r plus 1. Now we break this summation n plus 1. If we put r is equal to 0, that will be gives 1 n plus 1 c 1. If we put r is equal to 1, that is minus 2 n plus 1 c 2 and so on minus 2 to the power n plus 1 c n plus 1. Therefore write n plus 1. Now we write this expression again in summation form and see the how it is changed. It is run for 1 to n plus 1. So we change the variable r to s. S is 1 to n plus 1 and nth term is always n plus 1. So that is n plus 1 cs and involved is it is 1, then minus 2 up to minus 2 to the power n. So it is run from s is equal to 1 to n plus 1. So that is minus 2 to the power s minus 1. Therefore it is 1 over n plus 1 summation run for s is equal to 1 to n plus 1 minus 2 to the power n by minus 2 n plus 1 cs. So Pn is equal to, we get 1 over minus 2 n plus 1 summation run s is equal to 1 to n plus 1 minus 2 to the power n plus 1 cs. It is 2 to the power s, sorry, 2 to the power s. Now it is numbering is 1. Now see carefully, 1 minus 2 to the power n plus 1. If we break it is binomial expansion, then it is summation s is equal to 0 to n plus 1 minus 2 to the power s n plus 1 cs. If we break it here, suppose we write the general form 1 plus x power n plus 1 and put x is equal to minus 2, then it will gives 1 nc1, it is n plus 1 c1 x plus n plus 1 c2 x square up to n plus 1 c n plus 1 x to the power n plus 1. Here we put x is equal to minus 2, then it is gives this form. If we write this expression in summation form, then we will get this summation s is equal to 0 to n plus 1 minus 2 to the power s n plus 1 cs. Therefore that is minus 1 to the power n plus 1 is equal to summation s is equal to 0 to n plus 1 minus 2 to the power s n plus 1 cs. But our Pn is run from s is equal to 1 to n plus 1. Here s is equal to 0 to n plus 1. So we break it, s is equal to 1 to n plus 1. This imply minus 1 to the power n plus 1 is equal to 1 plus, why 1? Because when we put s is equal to 0 in here, so it is 1, n plus 1 c0, that is 1. So that's why it is 1 and rest of are same. So s run from 1 to n plus 1 minus 2 power s n plus 1 cs. This imply minus 1 to the power n plus 1 minus 1 is equal to summation s is equal to 1 to n plus 1 minus 2 power s n plus 1 cs. Now numbering it 2. From 1 we get Pn is equal to 1 over minus 2 into n plus 1 summation n is s is equal to 1 to n plus 1. So that is that value, that is minus 1 power n plus 1 minus 1. Therefore Pn is equal to 1 over minus 2 n plus 1 minus 1 power n plus 1 minus 1. Now we put n is equal to 2k, any number 2 times some numbers, then p of 2k is equal to 1 over minus 2k plus 1 minus 1 power 2k plus 1 minus 1, because we need actually p of 2n. So we want to find p of 2k type, then we replace k by n. So therefore it is 1 over minus 2k plus 1, here is minus 1 power 2k into minus 1 minus 1. This is gives 1. Therefore p of 2k is equal to 1 over minus 2k plus 1. Here it is minus 1 into minus 1 minus 1. That is 1 over minus 2k plus 1. That is minus 1 minus 1, that is minus 2. So this minus 2 and this minus 2 cancel. Therefore p of 2k is equal to 2k plus 1. Therefore p of 2k is equal to 1 over 2k plus 1. This imply p of 2n is equal to 1 over 2n plus 1. This imply 1 over p of 2n is equal to 2n plus 1. In question asked find the value of summation n is equal to 1 to 25 1 over p of 2n. So put here the value of 1 over p of 2n and summation run n is equal to 1 to 25 2n plus 1. Now break this summation to come outside the summation. N is equal to 1 to 25 n plus summation n is equal to 1 to 25 1. Therefore that is 2 1 plus 2 up to 25 plus it is 25 times, that is 25. Now we know that 1 plus 2 plus 3 up to n is equal to n into n plus 1 by 2. So use here n is equal to 25, that is 2 into 25 plus 1 over 2 plus 25. Therefore summation n is equal to 1 to 25 1 over p of 2n is equal to, here 2 cancel, then 25 times into 26 plus 25. Therefore 25 plus 25 into 26 is equal to 25 common, 26 plus 1 is equal to 25 into 27, that is equal to 675. Now overall the questions we actually write Pn as a compact form in summation, then we write an binomial expansion 1 minus 2 power n plus 1. This expansion gives the value of Pn in very nice form. Then we find the value of p of 2k, some expression, then we replace k by n, then we get p of 2n, then finally get 1 over p of 2n and summation run for n is equal to 1 to 25, that value is 675.